Hello everyone. So today I'm going to do a task whose objective is to create a decision tree classifier and visualize it graphically. The main purpose of this task is like if we feed any new data to this classifier or the model which we'll build, it should be able to predict the right class. Okay. So firstly we are importing necessary libraries like pandas, numpy, seaborn and matplotlib for the visualization purpose. And now we are importing data. Here we are using the data iris dataset. So by this we can see that our dataset has 150 rows and 6 columns. So we'll explore this dataset a little bit. So if we'll check the data types, we can see here in our dataset only the species column is of object type. All other columns are of numerical type. And if we can see here, like species is our target variable which we have to calculate. Okay, so we'll do the data pre-processing here. So we are dropping the id column from this data set, and now if we'll check, we can see in our data set there is no id column. So now we are splitting our data set into dependent and independent features. Here the independent features are in x, and y is a target variable, that is species. Now we are checking missing values. So from here we can see we don't have any missing values in the data. So it's really good, we don't need to do the imputation. And now as we have seen above, we have both numerical and categorical features in our data set. So for now we are doing this, we are creating data frame for the numerical feature as we don't have any categorical feature in x. So we are doing only it for numerical. So here we can use this type function to check how our data is spreading across the table. What is the minimum value, what's the 1%, 10% data, like this. And from here we can see we if we want we can remove outliers. It would be helpful for predicting purposes. So here we are removing the outliers, and after removing we can see that our outliers got removed. Okay, so now we'll remove the numerical features with zero variance. After doing this, we have seen like there are no features which has a zero variance, so nothing would be dropped from this column, as it also has 4 columns as before. Okay, so as we have seen that whatever our target variable, that is species, is in a categorical feature, but our model will take input only the numerical feature. So firstly we'll encode the categorical variable, which is here the target one, y. It is a species. We can see like in y, which is our target variable, all these species are here. And if we want to see the unique values of this, we can see there are 3 discrete values in a y column. So now we'll generate a label encoding scheme for mapping each category to a numerical value by leveraging scikit-learn. So here, after doing this, we can see that we have changed the categorical features into the numerical, like as 0 for Iris setosa, 1 for this, and second 2 for Virginica. Now if we'll see y column again, we'll be able to see that we have 2 columns now in the y data frame, species and species label. But if we want to build our model, we don't need this species column. So for now we'll drop this one. We have dropped, and now we can see our data frame only have species labels. Now here we are doing the training and testing split. Here the testing size is 0.3, means only we have only 30% data from the test perspective. And now if we'll check the randomness, it's almost equal, so it's okay. Now we are building the decision tree model. Here we are using decision tree classifier because, as we have seen above, this is a classification problem. Okay, so here we are making our class predictions. Now we'll evaluate the model. Model evaluation is a very important step in our task. So we can see the accuracy, precision, and recall and urban score from this. And now we'll see our confusion matrix. There is like all the variables are across the diagonals. Nothing is outside that. So this is very good. Like we have true labels and the predicted labels are true. like we have true positive and the false negative in our data sets in a good amount. So now we are concatenating this x and y. X is having a independent feature, y having a dependent, which is a species label. And here we can see this is our final data set which we have made after doing the encoding and all the other outliers removal and all. So here we have tried to make a Lorentz curve. So from this we can see up to the uh, this size we can capture up to this third decile we can capture 30% of our data. And if we want to see, this is our gain chart and this is a lift chart, and final it comes to our model. This is our model, a decision tree model. Thank you.